I meant that thing. I was like, that's what I mean. I was like, no.
What did you say, son? What did you say? No, he said something.
Okay, we have
That's so stupid. Tell me how you get this right.
Okay, so yes, not yesterday, Friday we did a problem that both had sine squared and cosine squared. And I told you you could change either one, or then was it Hayden that came up with the other method, making it tangent? Okay, this one you don't have an option. You can only change one of them. Which one can I change? The sign, because why can I only change it? Because it's squared. You can't change things with Pythagorean that are not squared. Okay, so I can't change cosine. So since I can't change cosine, I have to figure out how can I make sine squared have cosines. So, okay, good. So sine squared, if you look at your Pythagorean identities, is the same as 1 minus cosine squared.
So do you just?
So you're gonna leave the 2 out?
Yes, because they'll have to get distributed.
Alright. And is that when you're gonna use like the odd and even stuff?
Not yet. We'll talk about that tomorrow. Okay, so then I would distribute. So I would have 2 minus 2 cosine squared equals 2 plus cosine. Okay, you want to get everything on the same side, and it'll make your life easier if the squared is positive. Okay? So if I want to get everything on the same side, if I want the square to be positive, then I'm going to have to add 2 cosine squared. What am I going to do with the 2's? Subtract, and what happens?
Zero.
They cancel each other out, right? So now I have 0 equals 2 cosine squared plus cosine. My clock's a few minutes slow, so just pay attention. Okay, how do you think you solve this now?
Factor out cosine.
Factor out of cosine, good. So then I have 2 cosine plus 1. And then I would set each one equal to 0 and solve. So I would have cosine equal to 0. And then I have 2 cosine plus 1. Okay, so how do I solve 2 cosine plus 1 equal to 0?
Subtract 1 is over 2.
Good. Okay, so I want all of the answers where cosine is 0 and all the answers where cosine is negative a half. So where is cosine 0? Anybody know? Cosine's your x.
At 90 degrees.
90 degrees, what else?
270.
270. Okay, what about where cosine is negative a half? So where's your x negative a half?
240.
240, and what else?
120.
120. Okay, last one. Is everybody okay on number 4? Okay, what do you think we're gonna do on number 5? Do you think I need to change anything? You're gonna factor, but I don't wanna change anything. Why would I not wanna change anything? Because they're all signs, okay? So if I wanted to change this, I would be turned into cosine, but I don't want cosine because I want everything to be the same. Okay, we're gonna factor this. This is exactly the same as how you'd factor 2x squared plus 3x plus 1. Okay, it just now has signs with it. So like if I would do like my multiply and add tables, multiply to get 2, add to get 3, or 2 and 1. Okay, I can't do the shortcut because that's 2, so I'm going to split the middle. So I'd have 2 sine squared plus 2 sine plus sine plus 1. Okay, how do you factor with 4 terms? Grouping. So what can I factor out of the first group?
2 signs.
2 sine. And I'm left with sine plus 1. What about the second group? A 1. Sine plus 1. So I would have sine plus 1, 2 sine plus 1. Okay, where do you think we go from there?
Sine
equal to 0, good. So we're gonna find, first one, I would subtract 1. So I'm gonna find where sine is -1. Second one, how would I solve the second equation? Subtract 1 divided by 2, good. Okay, so I know where sine is -1, sine's your y, right? Okay, so where's y -1? 270. That's not very good too. Okay, what about sine -1/2? 210 and 330. Good. Okay, so now we've done enough to get us through page 396.